Hi, everyone. So we talked about the Bohr model and how when electrons absorb energy, they're able to jump to a higher energy level. And when they want to jump to or fall to a lower energy level, they have to release energy. And that energy is in the form of light. So let's talk a little bit more about what light is. So light travels in waves, which are disturbances that transfer energy over a distance. So energy is being transferred over a distance. And light is a form of electromagnetic energy. Electromagnetic energy is light. One thing I want you to keep in mind, light isn't just the stuff that we're able to see with our eyes, what's coming from your computer screen, what's coming from the lights above your head. There are light waves that we can't see with our own eyes. It's impossible. But there's energy being transferred all around right now. So the diagram that you see below, we're going to talk about the different parts and properties of an electromagnetic wave. As we're going through and talking about it, I want you to be sure to label the wave on your notes paper so you can refer back to it in the future. So the first part of a wave we're going to talk about is the crest. The crest is the highest point on a wave. We have a crest here on the left. It's the highest point. Then the two in the middle, as I already have labeled, and then the one over here on the right. So the highest point on a wave, crest. Next is the trough. This is the lowest point on a wave, the dips, the ditches of the waves. So it is the bottommost area. And we can see that there are 3 points that are the lowest points. So the crests are the tops of the mountains, and the troughs are the bottom of the ditches. Next, we have wavelength. And this measures the distance of one complete wave. There's a few ways that we can do this. The easiest way to think of wavelength is from crest to crest or trough to trough. But that's not the only way to measure a wavelength. Remember, it's one complete wave, one cycle. If I started mapping my wave right here, one complete cycle would be an up and a down and then a back, stopping at the same position. So wavelength doesn't just have to be top to top, bottom to bottom. It is one complete wave cycle. Keep that in mind. Next is amplitude. So amplitude is the maximum height of a wave measured from the resting point. Make sure you label resting point on your wave as well. So resting point is the position that a wave would have if no energy is being transferred. So no energy is being traveled over a distance. There is no wave. Measuring from that I'm not moving position to the crest is one way you can measure the amplitude. It is also from the resting point, I'm not moving point, to the lowest point, the trough. So keep that in mind. Amplitude can be from the resting up or the resting down. We just want to know the height or even the depth of the wave. So we're talking about wavelength. We're talking about the wavelength and how it's one complete wave. So the number of complete waves that move past a given point in 1 second is known as the wave's frequency. So frequency and wavelength are related, as you can clearly see in these two photos. So if you have waves that are really close together, there's a high frequency. Think about it, frequency. How frequently is it happening? How often is it happening? If there's a high frequency, it's happening a lot. So the waves are getting closer and closer together. If the waves are close together, it's moving really fast. High frequency. Now, if you have waves farther apart, I call these lazy waves. They have long wavelengths, they're far apart in a low frequency. So waves that are close together are hyper. They're moving a lot. They're close. Lots going on. Where if they're farther apart, I call those lazy waves. Long wavelength, not happening as frequently. And we use the unit Hertz, HZ. No, not the car rental company, hardy har. But Hertz is an actual measurement, a unit that we use to measure how frequently waves are occurring. So we can take this idea of electromagnetic energy and we can view it over what's called the electromagnetic spectrum. So this is the complete range of frequencies of electromagnetic waves. I said we call the electromagnetic spectrum. We have multiple types. We have radio waves, which have very long, lazy wavelengths. We have microwaves, infrared, visible. So visible light is the only part of the electromagnetic spectrum that we can see with our vision. It's visible. Ultraviolet, X-ray, and gamma. So gamma has the highest frequency. The waves are very, very, very close together. And we can use all parts of the electromagnetic spectrum, all wavelengths, to gather information about distant objects. So stars, galaxies, everything we know about them is because of the electromagnetic energy they emit. Remember, light isn't just what we see. Light is also radio waves, microwave, infrared, ultraviolet, X-ray, gamma. All of those are forms of light. So the electromagnetic spectrum, we know. The radio, we talked about how they have low energy. They're lazy, long wavelength. And as you move from radio towards gamma, they have a high frequency. They're hyper, high energy. They're very close together, so a short wavelength. We know the visible light spectrum can be broken down into the rainbow, our Roy G. Biv, red, orange, yellow, green, blue, indigo, violet. If we notice, the red end of our spectrum is towards the lazy end of the electromagnetic spectrum in general. The violet blue end of the visible spectrum is on the hyper side. So when we're looking at visible light, the red is lazy, the blue violet end is the hyper. So red light has less energy compared to blue and violet light. All right, go ahead, make sure that you go back and you fill in anything you may have missed. And the check-in for electromagnetic energy will be posted soon. See you later.